2.6a, rational functions. But before we talk about rational function, what's a rational number? What? A number that can be written as a fraction, exactly. So that leads us into a rational function. A rational function is, guess what? It's in what form? It's in fraction form. All right, so that's what a rational number is, or a rational function. A rational number is something that terminates or has a repeating pattern. That's why we have Arnold here. All right, let's keep going. So we're going to find the domain of this rational function. Okay, so this is a pair function of a reciprocal, just 1 over x. All right, well, what can we not have going on in this fraction? If we have a fraction, what can the bottom not equal? 0. We can't have the bottom equal 0. So x cannot equal 0, true? And how do I write that in interval notation? We talked about this in chapter 1. How do I write that in interval notation? What's all the way left? Negative infinity. And then it goes to what? 0. And then I can't include 0, so then I start at 0, and then it goes to what? Positive infinity. All right? Now I want to talk about the behavior at x equals 0. So we're going to approach x equals 0 from the left, and we're going to approach it from the right. So if we substitute a negative 1, what do we get? If I substitute a negative 1 into this function, what do I get? I get negative 1, right? Okay, it's not a trick question. If I substitute a negative 1/2, what do I get? I get negative 2. If I substitute a negative 1/10, what do I get? Negative 10. Negative 100th is what? Negative 100, and so forth and so on. What's it doing? It's going really far what? Down. Okay, so when it gets to 0, it's going down from the left. That's what it's doing. All right, and then when I go from the right, if I substitute in 1, what do I get? 1. If I substitute in 1/2, I get 2, and then 10. And then what's it doing when it goes from the right of 0? It goes up. All right, so graphically speaking, when I approach 0, 0 is my problem area, true? All right, so when I approach 0 from the left, it goes down, and when I approach 0 from the right, it goes up. All right, let's move. So now let's talk about vertical and horizontal asymptotes. All right. So on horizontal asymptotes, actually let's talk about vertical first. A vertical asymptote is when we have a 0 in our denominator, but not only that, a vertical asymptote is a number over 0. Okay? So if you have any number over 0, that's going to create that vertical asymptote. Can you ever cross a vertical asymptote? You can't cross it. All right? So you can't touch a vertical asymptote. A horizontal asymptote is what's called an end behavior. And I'm going to freestyle these a little bit. You guys know how this works. So if your numerator is higher, you don't have one. Remember? If your numerator and denominator are the same, then you just look at its coefficients. And then if the denominator is bigger, it's y equals 0. So for instance, you have, let's say, y is equal to 3x cubed plus 2x, I don't know, over x squared minus 3x, I don't know. Where's my higher power? It's on top. So what's my horizontal asymptote? My higher power is on top, so I don't have any. All right, it's none. However, if you have like y equals, let's say 3x cubed plus 2x over 2x cubed minus 3x. Where's my higher power? They're the same. So what's my horizontal asymptote? I need to look at my coefficients. So what's my horizontal asymptote? Y equals 3/2. So now we have y is equal to 2x cubed plus 2x over, let's say something like 3x to the 4th minus 3x. Where's my higher power now? It's on the bottom. So if it's on the bottom, my horizontal asymptote is actually what? 0. So it's y equals 0. All right, y equals 0 is another name for what? The x-axis. All right. So if we were actually, let's put it into practice. Here we go. So if I have the function of 2x plus 1 over x plus 1, where is that one going to have a problem area? In my domain, where is it going to have a problem area? Okay, a fraction, remember? You said the bottom not equal to 0, remember? So what can it not be?
Not equal to 0.
Okay, negative 1, there we go. So x cannot equal negative 1. So that's where I actually have a vertical asymptote at x equals negative 1. All right, because it's not part of my domain. So that's why we have a vertical asymptote there. So now, if I talk about horizontal asymptotes, what do I need to look for? The higher powers. Where are my higher powers? They are the same. So then I look for the what? Coefficients. So I have 2 over 1. All right, so what is it? Y equals 2 as a horizontal asymptote. All right. Now, to figure out which way they go. So if I have these as my little asymptotes. Now, pick something on the left and the right. So I'm going to pick negative 2 because that's left of that vertical asymptote. True? If I substitute in negative 2 right here, if I substitute in negative 2, what would I get up top? I get negative 3 over what? A negative 1. So negative 3 over negative 1 is what? 3. So that would be above my horizontal asymptote. So that's why it's hugging above. Okay. So now I'm going to pick something to the right of my vertical asymptote. So what's something to the right of x equals negative 1? Like 0. 0 is to the right, is it not? So if I substitute in 0, what do I get? I get 1. Is 1 above or below this horizontal asymptote? It's below, so that's why it's hugging below. Okay? All right, let's do it again. This one's actually a very famous curve. It's called a Witch of Agnesi. All right, so we have 4 over x squared plus 1. All right, if you get through Calc 2, you're going to be doing Witch of Agnesis a lot. So I have 4 over x squared plus 1. Am I going to have any vertical asymptotes? I said the bottom not equal 0. Am I ever going to get it? No. Okay, so everything works in my domain. I'm not going to have a number over 0. However, let's look for horizontal asymptotes. So what would my horizontal asymptote be? Y equals 0. Why? Because the higher power is on the bottom. All right, so I have a horizontal asymptote at y equals 0. Let's look at this next function. I have 2 over the quantity x minus 1 squared. What can I not have on the bottom? Okay, I can't have 0 on the bottom, but what number, when I substitute it in, will it make it 0 on the bottom? 1. So I have a number 2 over 0 when I substitute in 1. So that's why I have a vertical asymptote at x equals 1. All right. Now, where's my horizontal asymptote? Where's my higher powers? The bottoms. So what do I get? I get y equals 0. Now, I got to figure out which way it's going. If it's kind of bending this way or bending down, I got to figure out which way it's going. So pick something left of my vertical asymptote. Like 0. If I substitute in 0 here, what do I get? 2 over 1, which is 2. Is 2 above or below y equals 0? It's above, so that's why it's curving upward. All right. How about 2? 2 would be to the right of x equals 1, would it not? So if I substitute in 2 here, what do I get? I get 2 again, right? So that would be hugging above. Find all the vertical and horizontal asymptotes, and we're going to actually sketch these. All right. So I have 2x squared over x squared minus 1. 2x squared over x squared minus 1. Anytime I see a quadratic, what do I try to do to it? I try to factor it. So let's factor it. So I have a 2x squared on top over what? X plus 1 and x minus 1. All right. So where are my vertical asymptotes? X equals 1 and x equals negative 1. All right, let's start sketching now. Why not? So at x equals 1, I have a vertical asymptote. And then at x equals negative 1, I also have a vertical asymptote. What's my horizontal asymptote? What do I need to look for? My higher powers. Where's my higher powers at? They're the same. So what do we need to look for? The coefficients. So what do my coefficients give me? 2. It gives me y equals 2. All right. So I actually have a horizontal asymptote at y equals 2. All right. All right. So now we got to figure out which way they go. So the options, it could do something like this, or something like this, or it could do something like this, or it could even do something like that, or this, or this. And we got to figure out what it's doing. All right. So let's pick something left of negative 1. What would you choose? Negative 2 sounds great. All right. So if I substitute in negative 2 here, what do I get up top? I get 8. What do I get on the bottom? I get 3. So I get 8/3 when I substitute in negative 2. Agreed? Is 8/3 above or below 2? It's above. It's above. So that's why this will hug above. All right. Well, let's do the right of 1. All right, I'll save the middle for in a second. So let's do the right of 1. So let's pick something like 2. If I substitute in 2, what would I get again? 8 over 3 still. All right, so is that above or below? 8/3 is above y equals 2. All right. All right, so now we're actually going to need like a little fraction. All right. So I'm not going to pick 0 because that's like in the middle of those asymptotes. So let's pick something a little bit closer to negative 1 or 1. Like 1/2 sounds great. All right, so if we substitute in 1/2 now, what's 1/2 squared? 1/4. And so now I have 2 times 1/2, which is, or 1/4, I mean, 2 times 1/4 is 1/2. So right now I end up having 1/2 over, what would I have here? I'd have 1/2 squared, which is 1/4, minus 1, which is negative 3/4, right? So it's actually going to be a what? A negative, right? Do I really care what perfect number it is? No, but it's going to be below 2, is it not? It's going to be below 2, and that's really what I care about. We got a negative going on down here, all right, at 1/2. So that means it's going to start hugging that way. All right. If we substitute in negative 1/2, what's it going to do? It's still going to give me a what? It's still going to give me a negative. And so that's why it's going to be hugging down there when I get to that point. All right. So now I have x squared plus x minus 2 over x squared minus x minus 6. What do I have both things going on here? Okay, I do. I could do horizontal asymptote, but I have quadratics. And before I do anything, what would I probably do with quadratics? F them up. So let's factor them. Let's see what happens. So if I factor them, what do I get? X plus 2 and x minus 1. And then on the bottom, what do I get here? Okay, I'm going to say x plus 2 and then x minus 3, just to show something. So what happens? My x plus 2's cancel. All right? This is something that you should probably write down. You get a whole when you get a 0 over 0. Okay? A whole is a 0 over 0. A vertical asymptote is a number over 0. Okay? And what I mean by that is when something cancels out, it's going to create a whole. What x value will create this whole of 0 over 0? -2. So I'm going to have a whole at -2 comma something. All right? And what that something is I'm actually going to back substitute it in here. All right? All right? So what do I get up top? I get -3 up top, and what do I get on the bottom? I get a -5. So I have a -3 over -5, and we're going to call that 3/5. So I actually have a whole at -2 comma 3/5. All right? From there, we can also get our vertical asymptotes and such. What's my vertical asymptote? What will give me a number over 0? 3. So we're going to call it x equals 3. Why do I have to say x equals 3 and not just 3? Because it's a line. All right? And then let's do our horizontal asymptote. So this is where we need to look for our higher powers. So, what are they the same? So what are my coefficients? 1. So now I get y equals 1. From there, I'm going to start graphing. So I have a vertical asymptote at x equals 3. I have a horizontal asymptote at y equals 1. And it also gives me a point, which is really nice. I have a whole at -2 comma 3/5. Now, -2 is over here. Is 3/5 above or below that horizontal asymptote? It's below. So that's really nice. I don't even have to come up with a new test point. So I have a hole going on down there. So what do we know? Is it going to hug above or is it going to hug below? It's going to hug below. All right? And so I already knew that part because I already kind of almost made a test point. All right? Now we need to figure out what goes on the right side. So I need to figure out if it's going to do this or if it's going to do this. All right? So what would we try to substitute in? 4. Now, you could substitute it in the original. I don't suggest it. Could you? Yes. However, this is what's called a simpler function other than at one point, and that point is -2 3/5. I would suggest substituting in right here. Okay? So if we substitute in 4, what do we get up top? A 3. What do we get on the bottom? 1. Is that above or below this y equals 1? It's above. So that's why it's going to hug above. All right? Real quick review. How do you make a vertical asymptote? A number over 0. What makes a whole? A 0 over 0. And go ahead and back substitute that to find the y value in the simpler function. All right? How do you find a horizontal asymptote? You need to look at the higher powers. What if the higher power is on top? What you do? The higher power is on top. It's none. If the higher powers are the same, then you look at coefficients. What if the higher power is on the bottom? Y equals 0. Okay? All right. Write those out. And then